Welcome back. This is going to be our Algebra 2 Sequence and Series, Lesson 5, Geometric Series Home Review, Part 6. And this will be the last one of our home review for this lesson. Please make sure you catch videos 1 through 5. And of course, if you find this video helpful, please give a like. Also, leave any questions or comments in the comment section below. So, a ball is dropped 16 feet above a hard surface. After each time it hits the surface, it rebounds to a height of 3/4 of its previous maximum height. What is the total vertical distance to the nearest foot the ball has traveled when it strikes the ground for the 10th time? Write out the first 5 terms of this sum to help visualize. Okay, so here we go. We are going to just kind of draw, in this case, this situation here. And we know this height is going to be 16. So when the ball drops, its first drop will be 16 feet. But then it rebounds up to 3/4 of that. And so 3/4 of 16 is equal to 12. All right, so it goes up 12. But then it comes back down 12 again. All right. And then at the second bounce, it goes up to 3/4 of 12. Now 3/4 of 12 is equal to 9. So here we go. So it goes back down 9. And so we see in this case that we have vertical distance going up and down. All right. And so now we want to figure out the 10th time. Now it says here the first 5 terms of this sum to help visualize. Well, we could keep going on in this case for our next bounce. In this case, we can be here and down here. And so each of the red ones are 3/4 times 9. And that's going to be, in this case, 27/4. But notice that we're doing 2 of each. All right, 2 of each. So what's interesting is that we only have one fall of 16. We have a rise and the fall of 12 and a rise and the fall of 9. And so since we're looking for when it strikes the ground the 10th time, okay, so when it strikes the ground the 10th time, the idea is that we're going to end up having the ball fall, in this case, I guess 10 times, but rising 9 times. Does that make sense? Okay, because after the first bounce, it rises up. After the first bounce, it rises up here. So that's our first rise. And then our second rise. So this is our first rise, and our second rise happens after the second bounce. All right, and so so once it hits the 10th time, it'll have risen. It will have risen 9 times. You're saying, why 9? Because in this case, it will be the number of bounces. In this case, will be one. Number of rises is 1 less the number of actual strikes to the ground. Okay, so we see in this case that we're going to definitely do. If we want to take the sum in this situation, we can do in this case is we can take our sum here of going upwards 9 times. And our first rising part, this is the rising. The first rising part would be, in this case, A1 would be 12. Our R value is going to be 3/4, so 0.75 to the 9th power over 1 minus 0.75. So that would be all the rising. Now the falling part, interesting enough, as the falling part, we will fall the same exact number of times as we rise, but we see we have one more extra piece of falling of 16. All right? So we rise by 12, we fall by 12. We rise by 9, we fall by 9. We rise by 27/4, we fall by 27/4. So this sum here is going to be the same exact for the falling heights, but plus 16. So falling will be 16 plus, well, S9. So what we can do is we can calculate the sum of the rising part, double that, and then add 16. So as a formula, we would find our total sum, our total vertical distance. Would be 16 plus 2 times the sum of 9, which would be, in this case, 12 times 1 minus 0.75 to the ninth power, close parenthesis, all over 1 minus 0.75. Okay? Now, again, I want to be very clear about this. Why are we doing twice? Because we see here that after the first bounce, the vertical rise is equal to the vertical fall. The vertical rise equal to the vertical fall. The vertical rise is equal to the vertical fall. So for those 9 times it rises, it will fall equivalent 9 times the same vertical distance. So the only part that we have extra for the falling is going to be that first time the ball falls off that ledge, if you want to call it, 16 feet. So we add that 16. So that's where that 16 comes from, that initial value here of the first fall. And so we have double of the rising part, because the falling part after the first fall is the same exact vertical height. So if we were to type in the calculator, we can do the following. We type in 16 plus 2. You know what? Here's what I would do. Okay, I'm going to do some pieces. That's where I get a little bit, careful. I want to find this first. So like I normally do. And so what I want to do is I want to take the 12 times the 1.75 to the ninth power, close parenthesis, divided by open parenthesis, 1 minus 0.75. Once I type this in, I will then multiply it by 2. And then the next step after that will be to add the 16. All right? So let's take a calculator here. So 12 times 1 minus 0.75 raised to the ninth power. Okay? And then we'll divide that by parenthesis 1 minus 0.75. Okay? Because it's 3/4. All right, we're taking 3/4 of our values multiplied by 3/4 every single time of the original height from before. So we find this numerical value to be 44.39593506. Now, if we want to, we could find the fraction here, and so hit math, enter. Oh, I guess not. All right, so that's okay. And the reason why it's okay, ladies and gentlemen, is because, well, they're asking us to round off here, so we'll end up rounding off at the very end. Now, we said after we found this height, we're going to multiply by 2. So times 2. So we get 88.79187012. And then after that, we're adding the 16 from the original fall. So we get 104.79. So 104.79. And we're going to go back and we see it round off to the nearest foot. Okay? To the nearest foot. And so this here ends up becoming 104. So 104.79 approximates to 105 feet as our total distance vertically traveled, vertical being up and down. Okay? All right, ladies and gentlemen, I hope this video was helpful. I hope the analysis of how we approach this, and hopefully the diagram was helpful in this case. We could have tried to calculate all the decimals, but we see that's really kind of gets a little bit tricky there, and rather instead we use our formula to find the geometric sum in this situation, because it is geometric sum, because we're seeing in this case that it is going to be change by 3/4 every single time. So our strategy was to figure out all the heights, the sum of the heights going upwards, then find the sum of the heights going downwards, and we noticed that the sum of the heights going upwards and downwards were exactly the same, except for that initial fall of 16. So we just kind of the uh, double the sum for the traveling upwards, and then at 16. Okay. All right, ladies and gentlemen, thanks so much for watching, and I hope this was helpful. Please, please, please give this video a like, and definitely leave questions or comments in the comment section below. And I look forward to seeing you in our next videos, definitely for our test review. Take care, bye.